Section 6.1, Graphing Systems of Equations, Day 2. Our essential question is, how do you solve a system of equations by graphing? How do you solve a system of equations by graphing? We talked about this yesterday, so a lot of this is going to be review. On this next slide in class, we would have students come up and click and drag. They're color-coded. The number of solutions could be 1, could be none, or could be infinitely many. When there is one solution, we found that those lines were intersecting. When there's no solution, they're parallel. And when there's infinitely many solutions, the lines are actually identical. When lines are intersecting, they have different slopes. When lines are parallel, they have the same slopes, but different y-intercepts. And when they're identical, everything's the same. So same slope, same y-intercept. When there's one solution, your lines cross. When there's no solution, they're parallel. And when they are identical, the graph actually looks like there's only one line on it. Okay, so our first system, you may recognize it's worded in the same way as it was yesterday. We have two equations that we're going to be graphing. The first one is not quite written in slope-intercept form, so we are going to have to do a little bit of work, not a lot. To get the y by itself, we just need to divide by 2. So I divide everything by 2, which gives me negative 3x plus 5. So I start my graph at 5 on the y-axis. My slope is negative 3. I can put a 1 under it to make it a fraction. So then I'm going to move down 3 over 1 to the right. Down 3 over 1. And then I can draw my line. My second line, again, not quite in slope-intercept form. So this one's going to require a little work. Just one step, subtract 3x on both sides. So y equals negative 3x plus 5, which happens to be exactly the same as my first equation. So my lines are going to be what we call identical. So what type of lines? They're identical. And then how many solutions? Infinitely many, because they cross at every point on the line. Okay, the next system . My first equation is not in slope-intercept form, and this is a little tricky, because when I subtract my x on this one, I have negative y equals negative x plus 1, and then that negative in front of the y is really a negative 1. So I need to divide by negative 1, and in front of the x I can put a 1. So what happens is, negative divided by negative is a positive, so positive 1x, and then a positive divided by a negative is a negative. So my intercept is negative 1, but my slope is positive 1, so I go up 1 over 1, and then I can draw my line. Okay, the second one, x plus y equals 5, this one's a little bit easier to rewrite because I just subtract the x. So y equals negative x plus 5. I can put my 1 in front and make it a fraction. So this one starts at positive 5, and it's going down 1 over 1. So right there is where they're going to cross. So these lines are intersecting, which means that they have one solution. And then that one solution we can name as an ordered pair. So from the origin, it's 3 to the right and up 2. So 3, 2 is my solution. So intersecting lines are formed. There's one solution, and that solution is 3, 2. The third example. So you can probably guess what's supposed to happen on this one, just because we had three different types of systems. So let's see if it's what we expect. So for this one, I need to rewrite it because it's in standard form. So I can subtract. Actually, I'm going to put a 1 in front of my x first. Now I can subtract that 1x on both sides. 2y equals negative 1x plus 6. And then I divide everything by 2. So now you can probably see why I wanted the 1 in front. So y equals negative 1/2 x plus 3. So on my graph, I start at the y-intercept of 3, and my slope is negative 1/2. So I'm going down 1 over 2 to the right. Down 1 over 2 to the right. So here's my first line. My second one is in standard form again, so it's going to require some work. I will subtract the 3x on both sides. 6y equals negative 3x plus 8. And then divide everything by 6. Everything by 6. So y equals negative 3 over 6 can reduce. So in lowest terms, it's negative 1/2. So negative 1/2 x plus 8 divided by 6. 8 divided by 6. That doesn't divide evenly. It's 1.3 repeating. 1.3 repeating. So, what happens here? We've got 1.3 repeating for our intercept. And then the slope goes down 1 over 2. So since the slope stayed the same, these lines are parallel and parallel lines have no solution because they do not cross. So we did see one of each. We saw one where the lines were identical, so they had an infinite number of solutions. One where they're intersecting with one solution, so we named it. And now this one where they're parallel, so there's no solution. You should be able to write your summary now, answering your essential questions. So go back and reread that essential question. Make sure that you have complete sentences. And here are your homework problems. Please use graph paper for your graphs. Use graph paper because if you are looking for the point where your lines intersect, it is not going to be so easy if you're using just plain white paper or notebook paper, because you very specifically are looking to name that point where the two lines cross if they're intersecting. So it's a lot easier if you use graph paper and use your slope, rise over run, and just continue your lines until they cross.